Assalamu alaikum. Today we'll be talking about the oxidation number. So basically the idea is something like that. In sodium chloride, as an example, actually sodium contains 11 electrons and chlorine contains 17 electrons. So in order to form sodium chloride and to form the ionic bond between the metal and the non-metal, what happens is sodium loses 1 electron and chlorine gains 1 electron, so that the electronic configuration becomes 10 electrons for sodium and 18 electrons for chlorine. So sodium lost the electron in order to turn to the electronic configuration of the nearest inert gas to it in the periodic table, which is neon. And chlorine gained 1 electron so that it reaches also the nearest inert gas electronic configuration, which is argon. Now, sodium lost an electron and chlorine gained an electron. So how can we describe this action? We can say that this compound is ionic because the formed bond is between a metal and a non-metal. This atom, the sodium atom, lost 1 electron to chlorine, so this is ionic. So here sodium has a positive charge and chlorine has a negative charge, because sodium lost an electron. So when an atom loses an electron, it gains a positive sign. It becomes a positive ion. And when an atom gains an electron, it becomes a negative ion. And we put a negative sign. And basically, we don't write the 1 because it's 1 electron lost. But in another example, as in magnesium oxide, the natural electronic configuration of magnesium is 12 and oxygen is 8. Now, the nearest inert gas to magnesium and oxygen is neon. So we need to reach the electronic configuration of 10 electrons in magnesium and also 10 electrons in oxygen. So here magnesium loses 2 electrons and gives them to the oxygen, so that here becomes 10 and there becomes 10. It's also an ionic reaction. So this is an ionic compound. So here magnesium loses electrons, so it becomes positive. How many electrons does magnesium lose? It's 2. Oxygen gains electrons, so it's negative. And how many electrons does it gain? It's the same number that magnesium loses. So here we have -2. This is the oxidation number. The oxidation number is the number that refers to the charge of the atom inside a compound, if it was ionic or covalent, to show the positive or negative charge of the atom with the number of electrons lost or gained by this atom. So we were talking about ionic compounds. Now we want to talk about covalent compounds. We said in ionic compounds, like in sodium chloride, there is only one electron in the outer energy level or energy sublevel in sodium, and in chlorine there are 7. So there is one missing here. So what happens is that this electron leaves sodium and goes to chlorine to complete this energy sublevel. So the electronic configuration of each atom reaches the same electronic configuration of the nearest inert gas. But in covalent compounds, there is sharing. There's no losing or gaining. For example, in carbon dioxide, we have a carbon atom and 2 oxygen atoms. Now, the electronic configuration of oxygen, it contains 8 electrons. So we got 2 electrons in the first energy level and 6 electrons in the second energy level. The electronic configuration of carbon is 6. So we got 2 electrons in the first energy level and 4 in the second energy level. So it looks something like that. These are the oxygen atoms. This is the outermost energy level. And in carbon, we've got 4 electrons. So in the covalent compound, what happens is sharing electrons. So it becomes something like that. This will be the oxygen atom, this is the carbon atom, and this is the other oxygen atom. The 4 electrons at the outermost energy level of carbon don't leave the carbon atom, and at the same time they complete or fill the outermost energy level of both of oxygen atoms. So here in this case, this is a covalent compound, and we can say that this oxygen atom used 2 electrons of the carbon atom to fill its outermost energy level. So it kind of takes the electrons, but they don't remove them from the carbon atom. So here the oxygen is negative. And how many electrons does it use? It's 2. So we have negative 2. And this atom is also negative 2. And the valency of carbon is positive 4. So, because carbon used the 4 electrons in the outermost energy level to fill the outermost energy levels of both oxygen atoms. So we can write it this way. So plus 4 is the oxidation number for carbon, negative 2 is the oxidation number for oxygen. Now we know how to get the oxidation number in ionic and covalent compounds. But we have to know that the oxidation number of elements in covalent compounds, most of the elements have a fixed oxidation number, but some of them has an oxidation number that varies in some rare cases. For example, the oxygen, as we have just said, that its oxidation number is negative 2, because the outermost energy level contains 6 electrons, and we need 2 more electrons so that the outermost energy level will be completely filled with 8 electrons. For example, hydrogen peroxide, which has the chemical formula of H2O2. So here the oxidation number of hydrogen is positive 1. We can conclude from this we have two hydrogen atoms, each one shares 1 electron, so we get a total of 2 electrons. But at the same time, we have 2 oxygen atoms, not 1. So if the oxidation number of oxygen in this case is -2, and we have 2 oxygen atoms, so we get, if this is -2, we get -4. So here oxygen will need 4 electrons, so it doesn't work. So as hydrogen shares 2 electrons, oxygen must have to accept only 2 electrons. And since we have 2 oxygen atoms, the oxidation number of oxygen in this case will be -1, not -2. So it will be like this. We have 2 oxygen atoms, and we have the hydrogen atom. Now the hydrogen atom shares 1 electron, and each of the oxygen atoms contains 6 electrons at the outermost energy level. So we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So the oxygen atoms share electrons. So here we will have the electrons like this. So the 2 oxygen atoms share, each one of them share an electron, and at the same time the hydrogen shares 1 electron. So if we look at each atom, we will find that its outermost energy level is completely filled. Hydrogen contains 2 electrons. Each of the oxygen atoms contains 8 electrons in its outermost energy level, and also this hydrogen contains 2 electrons. Also, hydrogen has an oxidation number that varies in some rare cases. For example, we said that hydrogen's oxidation number is +1, as in the previous example. But what if hydrogen reacts with a metal? We all know that metals are always positive ions. They form positive ions because they lose the electrons in their outermost energy levels. So if the metal is positive and the hydrogen is positive too, no reaction will take place. So the oxidation of hydrogen in the reaction with metals is -1. So hydrogen reacts with metals to form metal hydrides, and hydrides refer to the hydrogen, where the oxidation of number of hydrogen is -1. For example, sodium hydride, NaH. We know that the oxidation number of sodium is +1, so apparently the oxidation number of hydrogen will be -1 because it will gain the electron given or lost by sodium. So sodium will lose its outermost energy level electron to hydrogen, so that hydrogen contains 2 electrons in its outermost energy level to be completely filled and reach the structure of the nearest inert gas, which is helium. Now we have some notes on oxidation number, and these are very important. So first, the sum of the oxidation number of atoms or ions inside a neutral compound is always 0. And the word neutral compound here is very important. For example, we have sodium chloride, or let's say we have carbon dioxide and we have the carbonate. Now, the oxidation number of carbon, as we mentioned, is positive 4 because it contains 4 electrons in the outermost energy level, so it loses them or shares them with the oxygen. The oxidation number of one atom of oxygen is negative 2. We have here 2 oxygen atoms, so we will have a total number of 4 electrons needed by oxygen. So here we have negative 4. On the other side, the oxidation number of carbon is positive 4, and the oxidation number of one atom of oxygen is negative 2. Here we have 3 atoms of oxygen, so we have a total number of 6 electrons that will be somehow gained or shared by carbon. So this will have negative 6, but carbon will only give just 4 electrons. So this compound is neutral, because if we sum plus 4, negative 4, we will get a 0. So this compound doesn't need any more electrons to be stable. So it will be neutral. It will not react with any element that will face it unless it was exposed to any chemical conditions. But the carbonate here, if we add plus 4, negative 6, we will have negative 2. So after the combination of carbon with 3 oxygen atoms, there are still 2 electrons needed so that this compound can be stable. So if this compound faces any other metal, it will react to gain the 2 electrons in order to be stable. So this is not a neutral compound. This is called a polyatomic ion, because in total this is put between brackets and we give it the oxidation number of negative 2, and accordingly this is an ion, but it contains a number of atoms, so it's called a polyatomic ion. So in order to be sure that you got the oxidation number right, you will know that the compound is neutral or not. If it's not neutral, you shall know the oxidation number, and then you can sum the oxidation number of the atoms inside. If they get the same result, so you are right. If it's different, so there is something wrong with the oxidation numbers you got for the electrons. So let's have some examples. Like sodium peroxide. So this is a neutral compound. So we begin with sodium, because we know that the oxidation number of oxygen, okay, it's negative 2, but in some cases it can be different. So we don't put the oxidation number of oxygen. We work with sodium. So the oxidation number of one sodium atom is positive 1. So here we have 2 sodium atoms, so we get a total number of 2 electrons. So here we have 2 oxygen atoms. Each oxygen atom will take 2 electrons. So as we got 2 atoms, so negative 2 divided by 2, we get negative 1. So the oxidation number of oxygen here will be negative 1 and not negative 2. Also, we'll have some examples for the polyatomic ions, like carbonate, which is negative 2. We got sulfate, which is also negative 2. We got ammonia, which has the oxidation number of positive 1. And finally, we got the nitrate, which has the oxidation number of -1. Finally, we can say that the oxidation number, if we know the oxidation number, this helps us to state the type of reaction that occurred between the elements to form a certain compound. For example, in sodium chloride, here sodium lost an electron and chlorine gained an electron. So the process of losing an electron and becoming a positive ion, this is called oxidation. And the process of gaining an electron and converting into a negative ion, this is called reduction. So if we know the oxidation numbers of atoms inside a compound, we can say which element was exposed to oxidation and which element was exposed to reduction. And so this is it for today, and this is the end of this chapter. And until the next time, I thank you for watching and see you.